hit record. It's already recorded.
Got it.
It's recording? Okay. Open up your spiral for
I didn't
notes.
remember any of it.
Okay. We're ready to get started.
We're discussing the word.
Awesome. Awesome. All right. So today we're going to talk about systems of linear equations. It's something that you guys have already talked about in your Algebra 1 classes and probably in Algebra 2. All right, so what we're going to do is going to be review, thank goodness, right? We're going to focus only on substitution today. Tomorrow you'll do elimination. Got it? All right, so let's get started. At the top of your page on your notes, let's call this Chapter 1. I'm sorry, how about Chapter 10, Section 1? Systems of linear equations. Okay, and today we are focusing on substitution. All right, so before we actually solve an equation, I would like to show you the three different types. We can have three different possibilities. The first possibility, I'm going to draw an X and a Y axis. Okay, we have two lines that intersect. They have one solution, don't they? And that's the intersection point is the one solution. And when we get to PreCal, we have a fancy name for that. We call this system consistent. So you're going to see that word in your book today, consistent. The second possibility is if we have two parallel lines. If your two equations are parallel to each other, we have no solution. And then the fancy name for a PreCal book, they call it inconsistent. All right. Does anybody know the third possibility? Raise your hands if you know the third possibility. Semi-consistent, that's an excellent guess. What do you think? Two solutions with two equations? Think you're, yeah, right. Think you're limited to two.
Like a parabola and a line.
Okay, how about let's limit it to just two linear equations. I like where you're going. You're thinking the parabola and a line would have two solutions. You're absolutely right. But what if you're limited to just two lines? A vertical line and a perpendicular, or a vertical and a horizontal, still would have one solution, wouldn't it? There's a third, and I'm wondering if you guys can remember that third one.
Two lines on top of each other.
There you go. I knew somebody would remember. Thank you. Two lines on top of each other. So that's our third possibility. So let's see if we can draw line number 1, and then if we draw line number 2 right on top of it, we have infinite solutions. And your PreCal book calls this condition coincident. So I want to show you an example of one of each of those kinds. Using using substitution. So example 1, here are two equations, and these are linear equations. And how about 5x minus y equals 6? So our goal is to solve the system. Using substitution only. So in your homework today, you're going to have equations set up just like this. They're in standard form. Your goal is to solve using substitution only. All right, so who remembers what that process starts with? How do we start? Go ahead, Farrah, say that louder. Okay, very good. We're going to solve for a variable. Which variable would you choose and which equation would you choose?
The first equation.
Okay, she said, Jess, you start with the first equation. How come you chose the first one? Just curious. It just looked like a good candidate? All right, and which variable would you solve for?
Y.
You would solve for y. Okay,
Or we could solve for X.
or you could solve for, it really wouldn't matter, would it? What about equation 2? If I said 2 is better than 1, could you see why equation 2 would be better than 1?
Yeah, because there's no, because Y is by itself.
Okay, yeah, there's no coefficient in front of the y at all, is there? You know why that's better? Any of you guys have any idea why this one would be better for us?
It has to be Y.
Because we're looking for y equals or x equals, very good. No fractions, very good. That's what we always try to avoid is fractions, right? Yeah, so Farrah, even though we definitely could have gone this way, we would have ended up with fractions. Here, if I solve for y in this equation, I'm not going to get any fractions. Our life will be so much easier. Okay, so let's do it. I'm going to subtract 5x from both sides. Negative y equals a negative 5x plus x, or 6, and then divide by a negative 1. So you end up with y equals 5x minus 6. All right. Now, Clay, what are you going to do with this equation now?
Wouldn't you take the top part of it and replace it to the y?
Very good. So, top equation, we're going to substitute a y.
Bless you.
So everywhere there was a y, we're going to leave parentheses, and in those parentheses we're putting the 5x minus 6. Okay, distribute correctly. Combine like terms. Let's subtract 12 from both sides. And divide by negative 7. Are we done when we get this answer, x equals what?
No, not done.
Okay, Mr. Fleming, what do we need to do next?
You have to put it in the second. You gotta put
Solve the y.
x into the second equation.
Okay, we're solving for y. Gabe said, does it matter whether we use the first or the second equation?
No.
Okay, so which one looks easiest to you?
Probably the second one.
Okay, sounds good to me. Let's do that right here. 5 times 1 minus y equals 6. So we get 5 minus y equals 6. Subtract 5. get our negative y equals 1. Divide by a negative 1, and y equals negative 1. Now, today I would like you to write your answers as an ordered pair. Put the x first, the y second, and that's what you're going to box up. 1, negative 1. So this is going to be a one solution consistent problem. Let's do one that is not consistent.
Could you put x equals 1 instead of y equals 5x minus 6?
Very good, absolutely. Why not? We have a y already solved for. This would have been so much faster. Excellent. All right, ready for example 2? Let's do one more. We've got 2x plus y equals 5. And 4x plus 2y equals 8. Okay, we're going to solve which equation looks like the more ideal one.
Number 1.
The top one. Very good, Johanna. Yeah, we've got a y without a coefficient. So it'll be the first one that we solve for y. So 2x plus y equals 5. Subtract 2x from both sides. Right, so it'll be the negative 2x that we substitute into y. Okay, distribute carefully. A positive times a negative gives us a negative. That would be plus 10. Now, what do you notice about the 4x minus 4x? They add up to 0, don't they? This adds up to 0. You end up with 10 equals 8. Now, ask yourself, does 10 equal 8? No, it does not. It does not equal 8, never will. So we say this is a no solution, not solution, solution. And we call this an inconsistent system. All right. So that was our type 2. Let's do type 3. Where we have an infinite solution. And y equals negative 2x plus 4. So here's one where we've got y already solved for us. Sam, question?
No.
You're good? All right, we're going to substitute negative 2x plus 4 in place of y. Okay, notice everywhere there was a y, I put parentheses, just in case there's a negative sign here. Positive signs are easy to distribute. Nothing changes. Okay, now 2x minus 2x once again adds up to 0. Thank you, Alexis. This time you end up with something that equals both sides, doesn't it? 4 equals 4. That is true. But we got rid of our variables, didn't we? So in this particular case, when they do equal each other, we call this an infinite solution. Infinite solutions. the system is coincident. Okay, so today your homework will be on page, let me tell you. You will be on page 738. And I want you to do 17 through 24 all, and 27 and 28. Okay, you should be able to finish those before you leave the class today. I think there's only 10 of them. All of them need to be solved with substitution. Any questions? Anything I didn't clear up? You guys are fantastic.